Assalamualaikum warahmatullahi wabarakatuh. We are from group 4, are going to present our discussion with me, Dillila Widdatina with ID number 132, and
me, Eni Puji Lestari with ID number 033.
And me, Bagus Surya Maulana with ID number 126.
Okay, for the question is, in each of the following problems, draw a direction field for the given differential equation. Based on the direction field, determine the behavior of y as t approaches to infinity if this behavior depends on the initial value of y at t equals to 0. Describe this dependency. Note that the right sides of these equations depend on t as well as y. Therefore, their solutions can exhibit more complicated behavior than those in the text. For the question 5t, y prime plus 1 plus t times y is equals to 3 cos t for t greater than 0. Okay, the question will be solved by Bagus.
Okay, thank you, Tilvi. So the next will be the solution for this problem. Before that, I'm going to share about the calculator of direction field. You can access it in the Google. You can just write it like this site, and then we are going to use it. For the first one, we have to determine the dependent and the independent variable for these problems. Because of these problems have a dependent y and independent is t, we have to change the x in here into t. And then we write the differential equation in here. We have to write it as the dy over dt it's equal to yxn, or the differential equation of it. And then like the problem, we write the 3 cos t minus y minus yt, and then we just click the enter of the keyboard. Okay, but we have to determine the requirement, that is the t is greater than 0, and then for this format access we change into t that is from 0 until 10 maybe, but you can write it as what you want. I'm going to write it as 10. Okay, just like this. And then if we have a differential equation, then we have to find the general solution of it. The general solution of it, we can write it as the y is equal to something. So we have to find the integral of the y over dt in here. And the solution that we have to solve, and we already solve it, our group, there is a 3 sine t plus c. There is a constant in here over 1 plus t to the power of 2 over 2 in the bracket like here. Oh, sorry, I forgot about the bracket in here. 3 sine t plus c, 1 plus t plus to the power of 2 over 2. Okay, that's right. So we just like the differential equation, just click the enter. Okay, you can see that the direction field and then the graph is matched. So the direction field should actually determine the gradients of the graph. So we can know that it's a graph that is in here, the horizontal, and the vertical is always 0 because the differentiation or the gradient is 0. But like something in here, there is some gradient in here, like here, and follow this graph. And then, so I think that's all for this calculator and then our presentation. So if you want to find the direction field from differential equation, you just can access this web and then put the differential equation, the general solution, and then the other requirement. I think that's my explanation. I give it back to my friend Eni Puji Lestari.
Okay, thank you, Bagus, for the explanation. I think enough for us. Thank you very much for your good attention. Thank you for your listening. May all those we have shared be beneficial for all of us. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.